Okay, we are going to talk about question 19 in chapter 4. And the question is as follows. Two different hardening processes, salt water quenching and two oil quenching, are used on samples of a particular type of metal alloy. The results are shown in table 4E2, which is in here. This is salt water quench and this is oil quench. Assume that hardness is normally distributed. A, test the hypothesis that the mean hardness for the salt water quenching process equals the mean. And let's see. Hardness for the oil quenching process, use alpha 005 and assume equal variances. B, assuming that the variances sigma 1 squared and sigma 2 squared are equal, construct a 95% confidence interval on the difference in mean hardness. C, construct a 95% confidence interval on the ratio sigma 1 squared over sigma 2 squared. Does the assumption made earlier of equal variances seem reasonable? D, does the assumption of normality seem appropriate for these data? We are going to work on that. First, we would like to open up the files, chapter 4. Okay. Okay, chapter 4. This is the data set we are opening up. We click OK. And a copy of the content of this file will be added to the current project. We say OK. Okay, so save project as, or maybe save project as chapter 4. Chapter 4, final questions. Okay, this is our project. Okay, let's continue. So what we are going to do in the first part, let's see. Okay, I'm going to make it a little bit larger. Okay, so here you see, first before we do meantep, we are going to do the work by hand. In the final exam questions, I'm gonna tell you whether you should proceed with Minitab or with hand solution, okay, or both. So but in these examples, I'm gonna do them both so that you learn both. And here, this is about the mean hardness for the salt water two processes, oil and salt water processes, and mu1 and mu2 could be equal to each other or not. So our alternative hypothesis is going to be they are different from each other. And we know that we reject H0 if T0 is greater than T alpha over 2 N1 plus N2 minus 2. But how do we know that this is a t-test? Because the variances are not known. They are assumed to be the same. That's why we have the t. Since the equivalences are assumed to be the same, we use SP here. Okay, so the SP formula is right here. We plug in the values. We have N1 and N2. We have that information. You can check N1 and N2 here too if you want, for 19. Okay, and here and here. In the question it is given as 2, 4, n is equal to, where is it? Okay, n1 is 10, n2 is 10, yeah? They are both the same. Therefore, we have n1 and n2 equals to 10, and S2, S1 and S2 are given like that. They are going to come from the data set. Okay, and we plug in and we find the values. Okay, actually you can find display basic statistics of let's see, 19. Okay, enter. We have the descriptive statistics for the first data, which actually we should be able to get S1. It says, okay, this is the same question. Standard deviation is 497. Okay, so if you take this, yeah, 497, do you see that 497 here, and we have 497 for S1 we are using. And similarly, if you go back to, so you can do the descriptive statistics to calculate in the exam, to calculate S1 and S2. Even if it is, we are doing the handmade solution, okay, you can do that by using that, that's acceptable. So we do that for the second one as well. Okay, to basic, so descriptive statistics, and we are going to do the second column in question 19, data set. So we enter, select, and click OK. And what's the standard deviation? 546, here 546, yeah. And also it says what n is, so it says that too. This n star, just ignore it, because in the data set it is filled up with the stars, the rest is like 15 stars in there. Don't worry about it. Okay, that's it. So we plug it in, and now for T0 we find the T0 is follows. Okay, T0 value x1 bar, sorry about that, phone is calling, my phone is on. Okay, so okay, T naught value is equal to x1 bar minus x2 bar. You can also get the x1 bar, right, the mean here 147, right, 147, and we go in here and we have 147.6, 147.6, and similarly x2 bar, you can find it 149.40, 149.40. So and then SP we calculated up here, and you can plug it in and then find the value, okay, for the T naught. So even if I ask you to do it by hand, you can use the statistics, descriptive statistics, to get an answer. And then you're going to use the tables to get the T alpha over 2 and 1 plus and 2 minus 2. Degrees of freedom is 10 plus 10 minus 2, which is 18. So we have, and alpha is 6005. If you take the half of it, this is 0.025. So we get this T0025, comma 18 from the table as 2.101. I'm not showing how to find it, but it's obvious from the T table. And then, so what do we do next? We compare T0. What does it say? If the absolute value of T0, which is 0.77, is bigger than this, then reject H0. But this is way bigger than the absolute value of this thing, so we fail to reject H0. We don't have enough evidence to reject H0. Okay, so so mu1 and mu2 are equal to each other. Okay, and so let's do the same thing for in Minitab. So we are gonna use, go to stat, basic statistics. We have 2 columns of data, right? And sorry about that. We will go slow. We have the 2 sample T because we have 2 populations and we have 2 sample data set. So 2 sample T, you go in there. Both samples are not in one column, they are in separate columns. Each sample is in its own column. So we have this sample 1, sample 2. So this is question 19, and then question, I mean C8 is this 19, the second column of question 19. And then we are going to just click OK. Okay, so there's a summary in here. mu1 is the mean of the data set in I think the C8, I mean C7, and mu2 is the mean of the data set in C8. We are interested in the difference, and we assume equal variances. I mean, we have to assume equal variances. By the way, so we have to redo that. Sorry about that. I'm trying to make it a little bit faster. So, okay. Okay, options. Confidence interval. Alpha is 0.05. Hypothesized difference is equal to 0. It's the same. Okay, we assume equal variances. Sorry about that. Okay, in here you can see others as well. Okay, we click OK. Now this is true. This should be correct. Okay, so yeah, equal variances are assumed for this analysis. It says now it's right. So we go down. You can see the summary of descriptive statistics summary of both of the data values that we need. Estimation for the difference. Okay, we have the pooled standard deviation because of the equal variances, and this is the confidence interval 95%, and this is the test we have, and p-value is given to be 0.451. This is way bigger than the alpha value 0.05, so it also confirms that we failed to reject H0. Okay, so this is it. This is the result. So you can see the p-value here as well in the solution, and then the f, you know, the f is degrees of freedom. What else? Pooled standard deviation is given here to 522, and pooled standard deviation here is 522.17. It is rounded up here. That's fine. Okay, next the question is assuming that the variances sigma 1 squared and sigma 2 squared are equal, construct a 95% confidence interval on the difference in mean hardness. So okay, so this we already got that the confidence interval here negative 6.71 comma 3.11, which is here as well, but this is handmade. You should also know how to apply the hand calculations in here. Okay, and in this confidence interval, the interval contains 0, so that's the same thing as we are in the acceptance region, not in the rejection region. That's why we fail to reject alternative hypotheses. I mean, we fail to reject null hypotheses. I'm sorry. Okay, that's how we do. And then in part C, construct a 95% confidence interval on the ratio sigma 1 squared over sigma 2 squared. Does the assumption made earlier equal variances seem reasonable? That's what it says. So whenever we have the ratio on the variances, we have the F test. You remember the F test. Okay, so we first construct a ratio, I mean confidence interval of the ratios, and we get these two values from the F table. 1 minus alpha over 2, alpha is 0.05, alpha over 2 0.025, 1 minus of that is going to be 0.975, and we have the degrees of freedom 9 and 9 for each, and here f 0.025 degrees of freedom 9 here for the f value, and the table gives us these two values. And the confidence interval is written as follows, but we can also find, this is the formula we get, but we can find it from the Minitab. So we go to basic statistics, and we have, in this case, no z, no t, but we have the two variances, so we are comparing the two variances now. Okay, the variances, both samples are in one column. No, each sample is in its own column. Okay, and then we click here so that it comes up. We enter, we select enter, and then the second data set, enter. Okay, what are the options? So we are interested in the ratio of the variances. Yeah, so let's see whether there's an option for the ratio of the variances. Yes, there is. Sample 1 variance, sample 2 variance. So we select that. Our confidence interval is 95%. Confidence level. Hypothesized ratio, okay, is 1. Okay, alternative hypothesis is gonna be not 1. Okay, what is the options? We have other options. Use test and confidence interval based on normal distribution. We said that it's normal distributed. Okay, so we are going to click OK. Okay, we have some summary in here, and on the back side we have this information. So this is the summary: sigma 1 standard deviation of this and standard deviation of the other. You'll get the ratio of both. Okay, F method was used, as we know, and this method is accurate for normal data only. Okay, that's why we use the F method. Descriptive statistics is a summary of each data and confidence interval for variances for each. Ratio of variances, estimated ratio is this much, and 95% confidence interval for ratio using F is this. Let's compare this result by hand with the solution done by hand. So it is really true, 0.21, 0.21, that's true, and the upper bound is 334, that's true. Okay, this matches. Okay, what else? So what you could do is you can transfer all these to the Word file when you're asked to do it on Minitab, yeah? Okay, send to Word, and it's gonna come out. It's gonna send it to the same Word that you started with. Where the cursor is actually, I'm not sure where my cursor was. Yeah, so I should move it up. Okay, maybe undo this and then put the cursor where I want my solutions to be. So this is 4.19. Okay, this is A, or which one? I think B. Yeah, this B. For the A, you can also transfer that. So I'm gonna redo that again. Okay, send this to Word. Okay, so what else do I want to send? I want to send the ratio of this, send to Word. And then descriptive statistics, to have it is good, send this to Word as well. Okay, and what else? I think that's it. You can also put maybe all of it. See, so there's this menu. After you're done, you can send to Word all of it. Let's see which part it's going to send it to. And you can also send graph to Microsoft Word. Okay, so everything is gonna appear in there. Click this part and say no, make it smaller so that I have room. See, I have this graph, there's this box plots and a chi-squared for both. These are just graphical purposes. Okay, it says f-test used and p-value, and we have this. Okay, I did that twice, I believe. Okay, I'm gonna erase one. Okay, let's go up. Okay, yeah, this is much better, so I'm gonna erase the ones that I did before, because there's a title here, which problem it did on top. So these are, instead of sending them one by one, you can send them all at once. Okay. Okay. And then let's make it small. Pardon, I have to put my arrow at the very end, so that next question is gonna go in there. So C maybe, right? I think it was B. Okay, let's see. Let's check. Oh, this was C. So I have to change that to C. Okay. So this is C, and next part is gonna be D, I guess. Okay, change this to D. Okay. Okay. Okay, then, okay, so the assumption of equal variances, does it seem reasonable? That was the question. So we have to look at, we can look at the interval. Where's our interval? Here's our confidence interval. Yeah, we have given these two information here. Let's see. Okay. Yeah. So that was the confidence interval, right? We found, and the ratio is equal to 1. That's inside here. So this is the acceptance region. So the assumption of equal variances seem reasonable, right? That's the acceptance region. In part D, does the assumption of normality seem appropriate for these data? So we have to check both datas, whether they are normal distributed or not. So for that, okay, so we are going to go to, where's our minitab? So I'm going to close this now. We go to graph, and we are going to go to probability plot. We can check both of them at once. So I'm going to put this here, select, and then put this here, select. Okay, and multiple graphs, overlay the same graph. That's fine. In separate panels of the same graph is fine. So you can choose whichever you like. So let's do that. We want to see them on the same graph, like in the solution here. Let's run it and see what happens. Okay, as you see, it is exactly the same. So what I'm gonna do is I'm gonna first of all send it to my Word file. Okay, and then you see the red ones. Okay, so we want to make sure that, so maybe it is sometimes it's difficult to see whether they are matching the right. It's very confusing like that. So I would suggest to you to do them on separate graphs. So on the same graph, okay, here it says this is that is the blue one is for the first data set and the square one is for the second data set, but still the lines are very confusing. Okay, so I'm gonna redo that. Don't save that. I'm gonna redo that on, probability plot. It's gonna be still multiple, but it's gonna be on separate. Yeah, these are two data sets and multiple graphs in separate panels of the same graph. Okay, so let's do that. Let's see what we get from that. It's a separate panel, so they should be shown separately. Okay, as you see, this is my first data, this is my second data, and this data set lies on this line and inside this two curves, and similar this around, I shouldn't say on this line but around this line, and similar this data set lies around this line and in this between these two curves, so both of them can be assumed to be normally distributed. We can also send this to our Word file as a proof. Okay, and underneath you can say they are normal distributed. I think I hit send it. Let's double check whether they are there. Yeah, they are there. So I make sure that my cursor is in a suitable place for my next entry. Okay, put it here. This was D. Maybe there is any too, so I'm gonna put E here. Let's see if there's any other question. Okay. Okay. Yeah, normal distribution seem to be reasonable. Okay, is there any question? Does the assumption normal seem appropriate for this data? Yes, it is. So let's skip that. Yeah, that's the end of the question 19. Okay, we'll meet in another question. This question was taken from Montgomery's control charts. Montgomery's statistical quality book.